Thank you very much. Can you see my screen?
All right now. Not yet. Yes, we see now. You can see it.
Yes.
Yes,
Okay.
go ahead.
Okay, thank you for the presentation. Yes, I'm going to present Project Solieva, which is from the LIFE program of European Commission. My presentation is titled Towards Circular Economy in Table Olive Sector, Opportunities for Resource Recovery. First of all, I'm going to present why Solieva, which was the reason that led to the preparation of this project and the execution of this project. And the reason is in order to give a sustainable solution to the challenges in the table olive production related to wastewater discharge. As you know, in the table olive production, a lot of brine is produced during the different production stages. Wastewater containing sodium hydroxide, sodium chloride, but also organic matter. And I would like to highlight their content in polyphenols. Due to this complex composition and also the variability of this wastewater during all the year, biological conventional treatments are not effective. So currently, this wastewater or these brines are discharged in evaporation ponds with some environmental impacts associated to them. In order to solve this problem, Solieva aims to demonstrate technical, environmental, and economical feasibility of the technology based on membrane, concentrator vacuum and spray dryer, and advanced solar evaporation in order to face these environmental challenges in the table olive sector. So we have different specific objectives as to demonstrate the innovative treatment at pilot scale, improve resource efficiency in the table olive sector with the reduction in the water consumption, to define valorization pathways for polyphenols that will be recovered during this treatment, also demonstrate environmental, social, and economic feasibility of this new technology, and define replication and transferability plans for this technology, scale up the Solieva process, and define a business plan, and finally provide some recommendations to update wastewater treatment legislation. Based on that, here you can see which is the Solieva approach, which is based in the development of an innovative treatment to enable the recovery of valuable resources from table olive sector. And how we can do it? By applying innovative technologies, a membrane-based technology based on the use of regenerated membranes for the separation of organic matter, and also the demonstration of advanced solar evaporation to achieve zero liquid discharge. By applying these technologies, we want to recover salt and water, and also to recover and valorize polyphenols. This is the treatment scheme, as you can see. From the wastewater collector, we feed a membrane pilot plant based on ultrafiltration and reverse osmosis. As I said before, the innovation in reverse osmosis is the use of regenerated membranes. From this membrane stage, we obtain two different streams. The permeate, which contains water and salt and a low concentration of organic matter. We are trying to remove as much as possible organic matter from this stream. This permeate then is fed to advanced solar evaporation, where we will recover salt. And on the other hand, for membrane stage, We recover rejection, where polyphenols are concentrated, and then through application of evaporation and spray dryer and also purification technologies, we can obtain a polyphenol-rich extract. I'm going to review a little bit each stage. The first one is membrane stage. The objective is to separate organic matter from salt. We apply ultrafiltration to remove suspended solids and also regenerative membranes. Regenerative membranes are membranes that are produced from end-of-life membranes from desalination plants. We apply a treatment in order to oxidize this membrane and obtain a tailor-made membrane specific for our to achieve our objectives regarding the separation of salt and organic matter. In the picture of the right side, you can see the different streams that are involved in this membrane stage. The first one is the wastewater from olive table that enters to the pilot plant. The second one is the ultrafiltration product after the removal of suspended solids. This ultrafiltration stream feeds reverse osmosis, and you can see in the third bottle is the rejection from reverse osmosis, which contains polyphenols and organic matter. And the last bottle in the right side, it's permeate, which contains water and salt. This permeate in this project is fit in the advanced solar evaporator, but also will be evaluated to be reused in the production process of table olive in order to reduce salt and water consumption in the company. Here you can see the pilot plan of advanced solar evaporation. These evaporators are based on a greenhouse effect. We can increase evaporation rate due to a higher temperature inside of these ponds, but at the same time we control the air conditions inside the ponds by using an advanced control. Okay, so we can control the aeration inside the ponds in order to ensure that humidity it's suitable to increase the evaporation rate of the water. The objective of applying this advanced solar evaporation ponds is to reduce the surface that is needed to evaporate wastewater. And at the same time, we can control the air emissions that are removed from inside these ponds. And as the last stage of the Solieva technology, the concentrate or the rejection from reverse osmosis is treated by a vacuum concentrator and a spray dryer to obtain a phenol-rich powder. You can see it in the slide. This powder is purified in order to recover polyphenols, and in the project, these polyphenols will be used to develop functional foods. The expected results of the project are based on the application of these technologies will be to complete the study of brine regeneration in European agri-food sector, reduction of 95% of table olive production wastewater that is sent to accumulation ponds or discharged in the environment, to recovery of 50% of polyphenols contained in this wastewater, to recover 30% of salts and, if possible, also sodium hydroxide in the case that the company has this stream. Also, to recover 55% of water to be reused, increase 50% of evaporation rate in comparison with natural evaporation. And also, we are developing a decision support tool to provide information about technical, environmental, and economic considerations to uptake this Solieva technology. This decision support tool will be uploaded in the website of the project. Finally, as a result, we would like to make recommendations to update the environmental legislation in the table olive sector and brine management. Thank you very much for your attention. If you have some questions, I will answer to you.
Thank you very much, Dr. Fàbrega, for this presentation. We saw already about olive meal waste from olive press, and now we see also from the table olive production. So it's very interesting that there's a lot of these applications. And as we said, it's good to see that not as a waste, but as a byproduct we can recover. Better so you can recover the salt, hydroxide, polyphenols, and minimize what's discharged to the environment. Thank you. Let's see if there are any questions.